what is the statement of mean value theorems and application. Now we further study of the mean value theorem. చూడండి ఇంత ముందు క్లాస్లో మనం మధ్యమూల్య సిద్ధాంతం యొక్క ప్రవచనాలు వాటికి సంబంధించిన సమస్యలు తెలుసుకుందాం. ఈ క్లాస్లో ఇంకా కొన్ని సమస్యలను మధ్యమూల్య సిద్ధాంతంపై ఇంకా కొన్ని సమస్యలను నేర్చుకుందాం. Right. The first problem is a is equal 0, 1, b is equal to e, 1 are 2 points on the curve y is equal log x base e is here. Right. If p is a point on the curve at which the tangent to the curve is parallel to the chord AB, then the x coordinate of p is what given is here. What asking is here, that x coordinate of p is given. What given? Right. So this the coordinate system is here. A coordinate system is here. So what the x values are is here 1 and whatever is here e can be taken is here. Right. At the log 1, right, this value is what the right, whatever the function is y is equal whatever is here log x can be taken. Right. This is the whatever is here log x graph can be taken. Right. This the point is a is 1, 0 is here and the y is equal to whatever the log x base e, this the our function, and b point is here e, whatever is here 1. Right. This the curve is here. Right. So this is the chord whatever is here AB. Right. Chord whatever is here AB. A and B are the 2 points on the curve and P is the point on the curve at which the tangent is parallel. P is the one of the point. Right. At which the tangent to the curve is parallel to the chord AB, then asking the whatever the x coordinate of whatever is here P. This is the problem. Right. What y is equal log x is given curve, a and b are the 2 points on the curve, the any one of the tangent is parallel to the chord AB and p is the given point, then asking the whatever the x coordinate of p is given. Right. According to this is nothing what the Lagrange's mean value theorem is. What Lagrange's mean value theorem? Given function is continuous and as the tangent means is differentiable, and this two whatever the tangent is parallel to the what coordinate chord of AB. Right. According to the whatever is here, the Lagrange's mean value theorem is here. There exists a point x0 belongs to whatever is here open 1, e is here, so that f dash x0 is equal to what happen is here f of right f dash x0 is equal f of b minus whatever is here f of a, f of e minus f of 1 by whatever is here e minus 1 can be taken. Right. Therefore f dash x0 is equal to what the f of e, what the f of e value is 1 minus f of 1 value is 0 by e minus 1 is here. Whatever our function f of x is equal whatever is here log x base e is here. Right. What the f dash x is here 1 by x is here. So what is the f dash x0? 1 by x0 is equal 1 by e minus 1 is here. What the x0 is e minus 1. So whatever the right, suppose p is equal to x0 whatever is here some y0 is here. What x0 x coordinate is here e minus 1. E minus 1 is the correct answer. Right. So suppose sometimes asking y value is here, what y is equal log x is here, x value is e minus 1. Right. Substitute the y value is here, y is equal to logarithm of e minus 1 base e is here. Okay. Right. So sometimes asking this a geometrical problem. Right. Without indirecting in Lagrange's mean value theorem is here, what is the x coordinate is here. Right. X coordinate is nothing but the whatever is here e minus 1 is here. చూడండి y is equal log x అనే వక్రంపై a, b బిందువులు రెండు బిందువులు అయితే AB రైట్ జ్వాకి సమాంతరంగా ఒక స్పర్శరేఖ p వద్ద గీస్తే రైట్ p బిందువు వద్ద గీస్తే p బిందువు యొక్క x నిరూపకాన్ని కనుక్కోమన్నాడు. రైట్. అంటే ఏంటండి ఇది y is equal fx అనేది వక్రం, AB అనేవి వక్రంపై రెండు బిందువులు అవుతూ p బిందువు వద్ద స్పర్శరేఖ AB జ్వాకి సమాంతరంగా ఉంది. అంటే ఇది లెగ్రాంజెస్ మధ్యమూల్య సిద్ధాంతం యొక్క జ్యామితీయ వివరణ. లెగ్రాంజ్ మధ్యమూల్య సిద్ధాంతం ప్రకారం f dash x0 is equal f of b minus f of a by b minus a అయ్యేటట్లు x0 belongs to open 1, e వ్యవస్థ అవుతుంది. దీన్ని సూక్ష్మీకరిస్తే x0 is equal ఎంతండి e minus 1. అంటే రైట్ ఈ స్పర్శరేఖ AB జ్వాకి సమాంతరంగా ఉంటే ఆ బిందువు p యొక్క x నిరూపకం x0 అనుకుంటే x0 వాల్యూ ఎంతండి e minus 1. దానికి అనుగుణంగా కొన్నిసార్లు y విలువ కూడా అడుగుతూ ఉంటాడు. Right. So this is the geometrical applications of whatever is here Lagrange's mean value theorem is here. You get what the x coordinate of p is here e minus 1. Okay. Next problem, f is continuous function on closed 0, 5, differentiable on open 0, 5. Further f of 0 is 4, f of 5 is minus 1. If g of x is defined by f of x by x plus 1 for 0 less than or equal to x less than or equal to 5, then there exists a point c belongs to open 0, 5, then what the g dash c is equal to which value is here. What given? F is whatever is here, f is continuous function. f is continuous function on closed 0 comma 5, f is differentiable function, f is differentiable function on open 0 comma 5 is here, and f of 0 is equal to whatever is here 4, and f of 5 is equal to -1. This is the given hypothesis. First read the problem. What hypothesis here? Next, given g of x is defined by f of x by x plus 1 is here. Right, where for 0 less than or equal to x less than or equal to 5 is here. You observe, right, what the right, 0 plus 1 less than or equal to x plus 1 less than or equal to 5 plus 1 is here, means x plus 1 is not equal to 0. That's why gx is defined is meaningful can be taken. Why denominator is not equal to 0, x plus 1 lies between 1 and 6, the gx is the meaningful is here. And given f is continuous function, and f is continuous function, x plus 1 is also a continuous function, x plus 1 is not equal to 0, the imply g is also a continuous function in closed 0 comma 5 is here. And also given f is differentiable function, x plus 1 is also differentiable function, fx by x plus 1 is also differentiable function in the open interval, whatever the open 0 comma 5 is here. Therefore g is satisfying, right, what the continuous and differentiable, g is satisfying. Right, what are the conditions of the Lagrange's mean value theorem is here. Apply Lagrange's mean value theorem to the function g in the interval whatever is here closed 0 comma 5 is here. According to the Lagrange's mean value theorem, there exists point c belongs to open 0 comma 5 is here, so that g dash c is equal to is here g of 5 minus g of 0 by whatever is here 5 minus 0 is here. Right, therefore g dash c is equal what, g of 5, g of x equal this one, g of 5 is equal f of 5 by 5 plus 1 6 is here. Right, what the g of 0 is here, g of 0 is here, f of 0 by 0 plus 1 is here, by 5 minus 0 value is 5 is here. G dash c is equal what the f of 5 is given what, minus 1 by 6 is here, minus f of 0 value is whatever is here 4, right, 4 by 1 is 4, by whatever is here 5 can be taken is here, minus 1 by 6, right, minus 4 by 5 is here, simplify we get is here g dash c is equal, simplify this one is here, g dash c value is here minus 5 by 6 is here. Right, so simplifying this one we get g dash c is equal minus 5 by 6 is here. Here direct, not applying the whatever the Lagrange's mean value theorem to the function fx is here, so fx defined in terms of other function g of x is here. Now apply the function Lagrange's mean value theorem to the function g is here, we get the result is here. First, what, given f is continuous function, f is differentiable function, at endpoint function values are given, gx is defined gx is defined in terms of what, fx, and denominator is x plus 1. First you check x plus 1 is 0 or not. Right, clearly x plus 1 is not equal to 0, that's why this function is meaningful. Right, and the fx is continuous and differentiable, gx is also continuous and differentiable, and denominator is not equal to 0 is here. Right, applying the Lagrange's mean value theorem to the function g, you get g dash c is equal to minus 5 by 6 is here. Right, so required answer is minus 5 by 6. చూడండి, f అనేది క్లోజ్డ్ 0 కామా 1 పై అవిచ్ఛిన్న ప్రమేయం, ఓపెన్ 0 కామా 1 పై అవకలనీయ ప్రమేయం, మరియు f of 0, f of 5 ఇచ్చిండు, g of x ఈక్వల్ టు fx by x plus 1, g ని f లలో నిర్వచించిండు. రైట్, అయితే g dash c is equal, c belongs to open 0 కామా 1 0 కామా 5 అయ్యేటట్టు g dash c విలువ కనుక్కోమన్నాడు. ఏమి ఇచ్చిండండి, ఫస్ట్ ఇట్లాంటి సమస్యలలో ఇవ్వబడిన సమస్యని చాలా జాగ్రత్తగా చదవాలి. f అనేది క్లోజ్డ్ 0 కామా 5 పై అవిచ్ఛిన్నం, f అనేది ఓపెన్ 0 కామా 5 పై అవకలనీయం, f of 0 ఇచ్చిండు, f of 5 ఇచ్చిండు. రైట్, g of x ఏమి ఇచ్చిందండి, f of x by x plus 1, ఎక్కడ x అనేది ఎక్కడెక్కడ ఉందండి, 0 నుంచి 5 వరకు, హారంలో ఏముందండి x plus 1, సో మొత్తం చూస్తే x plus 1 అనేది దేని మధ్యలో ఉందండి, 1కి 6కి మధ్యలో ఉంది, కాబట్టి x plus 1 0 కాలేదు, కాబట్టి ఇది నిర్వచితమైన ప్రమేయము. రైట్, సో నెక్స్ట్ g of x నిర్వచించినాము, fx అవిచ్ఛిన్నం కాబట్టి gx కూడా అవిచ్ఛిన్నం అవుతుంది, x plus 1 కూడా అవిచ్ఛిన్నం, నాట్ ఈక్వల్ టు 0. gfx అవకలనీయం కాబట్టి g of x కూడా ఏమవుతుంది, అవకలనీయం అయిపోయినాయి, x plus 1 కూడా అవకలనీయం. రైట్, ఈ gxకి లెగ్రాంజ్ మధ్యమూల్య సిద్ధాంతం యొక్క అన్ని నియమాలను పాటించింది. లెగ్రాంజ్ మధ్యమూల్య సిద్ధాంతం ప్రకారం g dash c is equal g of 5 minus g of 0 by 5 minus 0 అయ్యేటట్లు c belongs to open 0 comma 5 వ్యవస్థం అవుతుంది. రైట్, అంటే g dash c is equal g of 5 ఎంత అండి, f of 5 by 5 plus 1, g of 0 వాల్యూ ఎంత అండి, f of 0 by 0 plus 1 by 5 minus 0 5, దీన్ని సూక్ష్మీకరిస్తే రైట్, సో g dash c is equal what, minus 5 by 6, కాబట్టి కావాల్సిన ఆన్సర్ ఎంత అండి, minus 5 by 6 is here. The next problem, Rolle's theorem holds for the function fx equal x cube plus mx square plus nx on the interval closed 1 comma 2 and the value of c is 4 by 3, then asking m comma n values. What? The function, given function is f of x is equal x cube plus mx square plus nx in the interval is I is equal closed 1 comma 2 is here. F satisfy and c value is here, and c value is here, whatever is here, 4 by 3, and all conditions of the Rolle's mean value theorem satisfy. Then what asking m comma n values is here, given function, interval and c value. F satisfy already all conditions of the Rolle's mean value theorem is here. What is the Rolle condition? F is continuous, polynomial continuous. Okay, F is polynomial differentiable, second condition is also satisfied. Right. What is the Rolle's theorem? Third condition is here. F of 1 is equal to what? F of 2. And according to the Rolle's theorem, C already belongs to open 1 comma 2. F dash C is also equal to whatever is here. 0 is here. Right. What is the f of 1? F of 1 is here 1 cube plus m into 1 square plus n into 1 is here is equal 2 cube, right, plus m into 2 square plus n into whatever is here, 2 is here. Right. This is the one of the equation. This equation simplify is here 3m plus n is equal to whatever is here minus 7. Equation 1 is here. You observe. Alright, 3m plus whatever is here, 3m plus n is equal to minus 7. And also what is the f dash x? The f of x, this one. What is the f dash x is here? Right, 3x square plus 2mx is here plus whatever is here n. Applying this one, f dash c is equal 3, right. What is the f dash c value is here? 4 by 3 is equal to 0. Right, 3 into whatever is here 4 by 3 whole square plus 2m into whatever is here 4 by 3 plus n is equal to whatever is here 0 is here. Simplifying this one, you get the equation 8m plus 3n. 8m plus 3n is equal, right, simplifying this one is here minus 16 is here. This is the equation whatever is here. To solving 1 and 2 is here, m is equal to minus 5 and comma n is equal to whatever is here 8. M is equal to minus 5, m is equal to minus 5 is here, m is equal to what? Minus 5 is here, and n is equal to 8 is here. M is equal to minus 5, m is equal to minus 5 is here, and n is equal to whatever is here 8. Right, m is equal to minus 5 and n is equal to 8. This is the correct answer is here. What given? Right, given function already Rolle's theorem is valued. Right, and C we get 4 by 3. Asking m comma n values given is here. What given? First f is function. Right, given interval. Conclusion of the Rolle's theorem is C is given. Asking m and n values is here. First f is polynomial continuous, f is polynomial differentiable, and third condition f of a is equal to f of b, f of 1 is equal to f of 2. Applying the right Rolle's theorem, f dash c is equal to what? 0, means f dash 4 by 3 is equal to 0. Right, applying f of 1 is equal to f of 2, we get the one equation. F dash c is equal to 0, applying the condition 2, solving 1 and 2 is here, we get m is equal to minus 5 and n is equal to what? 8 can be taken. Right, next problem. If the polynomial equation a n x power n, a n minus 1 x power n minus 1, a n minus 2 x power n minus 2, a 2 x square a 1 x plus a0 is equal to 0, n being the positive integer, has two different real roots alpha and beta between, right, alpha and beta. Then between alpha and beta the equation has exactly one root, almost one root, at least one root, no root can be taken. Okay. First given polynomial equation is here, f of x is equal a n x power n plus a n minus 1 x power n minus 1, a n minus 2 x power n minus 2 plus dash dash is here, a 2 x square plus a 1 x plus a 0 is equal to 0, n is whatever is here positive integer is here. This is the polynomial equation, and alpha comma beta two roots can be taken. Alpha comma beta two roots means f of alpha 0 and f of beta is also whatever is here 0. Right, f be the polynomial equation, alpha comma beta two roots means f of alpha 0, f of beta is 0. We observe, right, then what f is polynomial, every polynomial is whatever is here continuous, right, and every polynomial is what? Differentiable can be taken is here. Right, so what the f is continuous function, differentiable function, alpha comma beta roots means f of alpha 0, f of beta 0. Then what? F satisfying all conditions of the whatever the Rolle's mean value theorem is here. According to the Rolle's mean value theorem, there exists at least, there exists whatever is here at least, right, one C belongs to whatever is here, at least one C is here, so that f dash C is equal to whatever is here, 0, right. What is the f dash x is here? What is the f dash x is here? F dash x is here, an into x, n into x power n minus 1 plus n minus 1 into n minus 1 into x power n minus 2 is here, plus dash dash lost a1, right, a1 is here, this is f dash x is here, right, means f dash C is equal to whatever is here, 0, means C is the root of this equation is here, right. At least how many is here? At least one root of the equation is here, which is nothing but the whatever is here, f dash x is here, which is the what? F of x is here. According to the Rolle's theorem, right, to f of x equal 0 has two roots alpha and beta, then the equation f dash x equal 0 has at least one root lies between a and b is here, that is whatever is here, at least one root of the equation f dash x equal 0, right. Rolle's theorem, between any two roots of the equation f x equal 0, at least one root of the equation f dash x equal 0 lies between alpha and beta is here, at least one or more can be taken, at least one can be taken is here, చూడండి, right. So right, an x power n minus 1, an minus 1 x power n minus 2, a1x plus a0 is equal 0 అనేది ఒక బహుపదీయ సమీకరణానికి ఆల్ఫా కామా బీటా అనేవి రెండు విభిన్న మూలాలు అయితే, రైట్, n ఇంటూ an x పవర్ n minus 1, n minus 1 ఇంటూ an minus 1 x పవర్ n minus 2 ప్లస్ a1 is equal 0 అనే సమీకరణానికి, రైట్. సో ఏముంటుంది? కనీసం ఒక మూలం ఉంటుంది, రైట్, ఒకటి కంటే ఎక్కువ మూలాలు ఉంటాయి, ఒకటే మూలం ఉంటుంది, అసలు మూలాలు ఉండవు అని ఇచ్చిన, రైట్. ఇవ్వబడిన బహుపదీయ సమీకరణం ఏంటండి? f of x, రైట్. ఆల్ఫా కామా బీటా అనేవి విభిన్న మూలాలు, అంటే ఎఫ్ ఆఫ్ ఆల్ఫా 0, ఎఫ్ ఆఫ్ బీటా కూడా ఏంటండి 0, ఎఫ్ బహుపది, ప్రతి బహుపది కూడా అవిచ్ఛిన్నం అవకలనం, మరియు ఎఫ్ ఆఫ్ ఆల్ఫా ఈజ్ ఈక్వల్ ఏమైంది? ఎఫ్ ఆఫ్ బీటా అయినది, రైట్. కాబట్టి ఎఫ్ అనేది రోలే సిద్ధాంతం యొక్క అన్ని నియమాలను పాటించినది. రోలే సిద్ధాంతం ప్రకారం, రైట్, ఎఫ్ డాష్ సి ఈజ్ ఈక్వల్ 0 అంటే కనీసం ఒక సి వ్యవస్థ కాదు, కనీసం ఒక సి అంటే ఒకటి అంతకంటే ఎక్కువ, రైట్. మనం ఇది ఎఫ్ ఆఫ్ ఎక్స్ అనుకుంటే ఈ సమీకరణం ఏంటండి? ఎఫ్ డాష్ ఎక్స్ అంటే ఎఫ్ ఆఫ్ ఎక్స్ ఈక్వల్ 0 సమీకరణం ఆల్ఫా కామా బీటాలు ఎఫ్ ఆఫ్ ఎక్స్ ఈక్వల్ 0 సమీకరణానికి మూలాలైనాయి, రైట్. రోల్ సిద్ధాంతం ప్రకారం కనీసం, రైట్, ఆల్ఫా కామా బీటాల మధ్య కనీసం ఒక్కటైనా ఒక సంఖ్య అయినా ఎఫ్ డాష్ ఎక్స్ ఈక్వల్ 0 సమీకరణానికి మూలం అవుతుంది. కాబట్టి, రైట్, సో ఎగ్జాక్ట్లీ వన్ రూట్, right, not to say that one, at least one means one or more, కాబట్టి at least one can be taken, కనీసం ఒక మూలం ఉంటుంది. కాబట్టి ద థర్డ్ ఆన్సర్, రైట్. రోలే సిద్ధాంతం ప్రకారం ఎఫ్ ఆఫ్ ఎక్స్ ఈక్వల్ 0 సమీకరణం రెండు మూలాల మధ్య ఎఫ్ డాష్ ఎక్స్ ఈక్వల్ 0 సమీకరణానికి కనీసం ఒక మూలం వ్యవస్థ అవుతుంది, కాబట్టి at least is correct. Next problem, if 4a plus 2b plus c is equal 0, then the equation 3ax square plus 2bx plus c is equal 0 has at least one real root lying in the interval. In which interval is here? Right. So what first given condition? Given condition is here 4a plus 2b plus c is equal to 0 is here. What about our equation is here 3ax square plus 2bx is here plus whatever is here c is equal to 0. Right. Given condition and equation. Right. Then at least one real root of this equation lies in which interval is here? This is asking is here. Right. So this type of problems you observing is here given condition and root are there and condition is given, how start the function, right, applying the Rolle's mean value theorem is here. How start the function is here? So the equation and integrating is here. What the integrating is here? Consider the function f of x is here. What about this integration is here? Ax power 3 plus whatever is here bx square plus whatever the cx, right. Consider the function f of x can be taken, right. We observe, right, f of x is equal to ax cube plus bx plus c. First, if condition and equation is given, right, so equation can be take integrate. This is the first start the f of x is here. We observe, right, so f of x is polynomial, always continuous and always differentiable, and we check our conditions is here. So what that one is here? F of 0 is trivially is equal to whatever is here 0. You apply f of 1. What the f of 1 is here? F of 1 is whatever is here a plus b plus c is here, right. Not our condition, not our condition is here. What the f of 2 is here? A into whatever is here 2 cube, right, plus b into 2 square is here plus c into whatever is here 2. Applying this one, right, whatever the 2 into whatever is here 4a plus 2b plus whatever is here c, right. Given 4a plus this value is whatever is here 0 and f of 2 is equal to what? 0 is here. This is not given, right. That's why f of 0 is equal to what? f of 2 is here, right? So f of 0 is equal to f of 2, continuous and differentiable is here, and f of 0 is equal to whatever is here, f of 2, right? So according to the Rolle's theorem, the at least one root of the equation is here, f dash x equal 0 in the interval whatever is here, closed 0 comma whatever is here, 2 is here. So therefore the given equation has at least one root in the interval open 0 comma 2 can be taken. What given condition is given, equation is given, at least one root lies in which interval is asking, right? This type of problems you think condition is given, equation is given, first consider the function is here. How consider the function? Given equation integrating, we get the function. Then apply the Rolle's theorem. What Rolle's theorem is here? Right, first we consider f of x is here, this the f dash x is here. So what the f of x is here, this condition is given, we trial f of 0 is 0 and f of 1 a plus b plus c is not given, that's why 0 1 is fail, right? Next one, right, 1 2 is also fail, 1 is fail is here and remaining is 2 is here, f of 2. Right, applying our condition 4a plus 2b plus c is 0, f of 2 is also 0, f of 0 is 0 and f of 2 is 0, right. So f is continuous and differentiable, f of 0 is equal to f of 2, f satisfy all conditions of the whatever is here, Rolle's mean value theorem. According to the Rolle's mean value theorem, there is at least one root, right, in the interval open 0 comma 2 of the equation f dash x equal 0. What is the f dash x equal 0? 3ax square plus 2bx plus c is equal 0. That's why one root lies between, at least one root lies between in the interval open 0 comma 2 is here. చూడండి 4a plus 2b plus c is equal 0 అయితే 3ax square plus 2bx plus c is equal 0 సమీకరణానికి కనీసం ఒక మూలం ఏ అంతరంలో ఉంటుంది అని అడిగినాడు. ఇవ్వబడిన నియమం, ఇవ్వబడిన సమీకరణం. ఇట్లాంటి సమస్యలు వచ్చినప్పుడు ఫస్ట్ మనం ప్రమేయాన్ని కన్సెప్ట్ తీసుకొని దానికి రోలే సిద్ధాంతాన్ని అనువర్తింప చేస్తే మనకు కావాల్సిన అంతరం కానీ మనకు కావాల్సిన విలువలు కానీ వస్తాయి, రైట్? కాబట్టి మనకి ఇవ్వబడిన ఏంటండి, ఇది రైట్ సమీకరణం. దీనికి ఫంక్షన్ ఏ విధంగా చేయాలంటే దీన్ని ఇంటిగ్రేషన్ చేయాలి. మనకి ఇంటిగ్రేషన్ ఏంటంటే దీన్ని ఇంటిగ్రేషన్ చేస్తే f of x ఈక్వల్ ax³ ప్లస్ bx² ప్లస్ cx ఇది సమీకరణం వస్తుంది. ఈ సమీకరణం ఇది బహుపది, అవిచ్ఛిన్నం, అవకలనీయం. f of 0 కనుక్కున్నాం, రైట్, డైరెక్ట్ 0 వచ్చింది. f of 1 a ప్లస్ b ప్లస్ c ఎలాంటి నియమం ఇవ్వలేదు కాబట్టి 0 1 అండ్ 1 2 రెండు కూడా ఫెయిల్ అయిపోయినాయి. ఇక మిగిలింది f of 2. f of 2 సూక్ష్మీకరిస్తే 4a ప్లస్ 2b ప్లస్ c 0 అయింది కాబట్టి f of 2 కూడా ఏమైందండి, 0 అయింది. f of 0 ఈజ్ ఈక్వల్ టు f of 2 అయింది. కాబట్టి రోలే సిద్ధాంతం, రైట్, క్లోజ్డ్ 0 కామా 2 అంతరంపై రైట్ సాటిస్ఫై నియమాలన్నింటినీ కూడా పాటిస్తుంది. కాబట్టి రోలే సిద్ధాంతం ప్రకారం 0 కామా 2 అంతరంపై ఓపెన్ 0 కామా 2 అంతరంపై f dash x ఈక్వల్ 0 సమీకరణం ఒక్క మూలమనే ఉంటుంది. వాట్ ద f dash x ఏంటండి, ఇది f of x, ఇది f dash x ఎంత, 3x² ప్లస్ 2bx ప్లస్ c ఈజ్ ఈక్వల్ 0 సమీకరణానికి రైట్ ఓపెన్ 0 కామా 2 పై కనీసం ఒక మూలమైన ఉంటుంది. నెక్స్ట్ ప్రాబ్లం, if from Lagrange's mean value theorem we have f dash x1 is equal f of b minus f of a by b minus a, then x1 lies between which interval is here, maybe equal to b and lies between a and b, maybe equal to a and lies between a and b, and only lies between a and b, not equal to a and not equal to b, and lies between a and b and equal to a and equal to b. This is the Lagrange's mean value theorem. What Lagrange's mean value theorem? F is continuous and f is whatever is here differentiable. Then there exists a point c belongs to open a comma b is here, so that f dash c is equal f of b minus f of a by b minus a is here. Right, we observe c belongs to open ab means is here, a less than c less than b is here, so that f dash c is equal to whatever is here, f of b minus f of a by whatever is here, b minus a is here. According to our theorem, what is the f dash whatever is here, x1, and what our x1 lies between open interval a comma b is here. In the Lagrange's theorem applicable in the right, f dash x1 is here, f dash c lies between always open interval a comma b is here. That's why our x1 lies between whatever the a and b's can be taken in the open interval, right? So given conclusion of the whatever the Lagrange's mean value theorem, where x1 lies between in semi interval or open interval or closed interval, according to the Rolle's theorem c belongs to according to the Lagrange's mean value theorem c belongs to open interval a comma b is here, means a less than c less than c is here. Given in the problem c replaced by x1 and x1 lies between whatever is here, a and b is here. Third one is correct, x1 is not equal to a and not equal to b is here, but lies between whatever the a and b can be taken. Right, next problem, Rolle's theorem is applicable in case of the function pi x equal to a power sin x, a greater than 0 is Rolle's theorem applicable for the function in which interval is asking. A is positive. What is the given function? Pi of x is equal to whatever is here, a power sin x. A is positive, exponential function is here. Okay, right. Applying the Rolle's theorem, what? Continuous, differentiable, and f of a is equal to f of b. This is the exponential function. Exponential function is always differentiable in its domain and the continuity in its domain, differentiable in its domain, and last condition is here, whatever condition is here, right, f of a is equal to whatever is here, f of b can be taken is here, right. What our function is here, pi of a is equal to whatever is here, pi of b can be taken is here, right. You take any interval, in the any interval is here, the whatever the values are not equal, any interval is here, close to 0, 1 can be taken, right. What the pi of 0 and pi of 1 you applying is here, pi of 0 is not equal to pi of 1, that's why in any interval Rolle's theorem is not applicable. Rolle's theorem is applicable, f of a is equal to f of b, and the next interval is here, close to 0 comma pi is here, right. What the pi of 0 is here, pi of 0 is a power sin 0, right, a sin 0 is 0, a power, right, sin 0 is 0, a power 0 value is 1, right, and pi of pi is equal to is here, a power sin pi is here, sin pi is 0, a power 0 value is also 1, both are equal, right. That's why the Rolle's theorem is applicable in the interval, right, close to 0 comma pi is here. So what the next interval is here, suppose the applying this one, right, pi of 0 is equal to what, 1 is here, can what the pi of pi by 2 is here, what the a power sin pi by 2 is here, a power sin pi by 2, the value is a power 1, a is given, right, greater than 0 is here, means a not equal to 0, means is here, pi of 0 is not equal to whatever is here, pi of pi by 2 is here, that's why this is not applicable is here, only the Rolle's theorem applicable in the interval close to 0 comma pi is here, right. If asking the Rolle's theorem is here, you start the third condition. What is the third condition? F of a is equal to f of b. Given function pi of x, a greater than 0 is here. Apply the Rolle's theorem in which interval is asking, right. So what the any interval is not possible to apply. Why? Our condition is pi of a is equal to pi of b. Suppose you take the example 0, 1, that is fail, not applicable is here, 0 comma pi applicable, both values are equal to 1, that's why applicable, 0 comma pi by 2 is not applicable, why? A greater than 0 is here, that's why the Rolle's theorem applicable in the interval close to 0 comma pi is here, right. Next problem, when the tangent to the curve y is equal to x log x is parallel to the chord joining the points 1, 0 and e is here, the value of x is dash, the value of whatever the value of x is dash is here. What given? Y is equal to x log x base e is here. This is the given function. Y is equal to what? F of x is here. Right. The what happened? Given points are a is equal to whatever is here, 1 comma 0, b is equal to what? E comma e is here. Right. You draw the curve is here. Right. A and b are the points are there is here. A and b are the points are there. Joining these 2 points is here. Whatever is here, chord can be taken. The tangent to the curve, right, parallel to the chord is here. You draw the tangent is the parallel to the chord is here. So what about that point is whatever the x value, suppose this point is whatever is here, p in the coordinate system is here, p is equal to x comma y is here, asking whatever is here, x value can be taken, right. When the tangent to the curve parallel to the chord AB is here, then the value of x is asking is here, right. What? Given function, and a point is given, b point is given, a is a comma f of a is here, and b is b comma whatever is here, f of b, and the tangent is parallel to the chord, apply the whatever is here, Lagrange's mean value theorem is here. What is the Lagrange's mean value theorem? X log x is always continuous function. Whatever the f dash x is here, f dash x equal whatever is here, log x plus whatever the x into 1 by x is here. The value is log x plus 1 is here. So which is also differentiable in our interval a comma b is here. What is our interval a comma b is here? Our interval is whatever is here, 1 comma e can be taken is here, which is also differentiable. And applying the whatever is here, Lagrange's mean value theorem, there exists a point C belongs to open 1 comma e is here, so that f dash c is equal f of b is what is the f of a minus f of 1 by e minus 1 is here, right. Whatever the f dash x is here, f dash x is log x plus 1, right. The value is here log c plus 1 is here, is equal what the f of e value is here, f of e value is e minus f of a value is here, f of a is 1, right. The value is 0 by whatever is here, e minus 1 is here, right. The value is here, right. You simplifying this one, right. Log c base e is equal to is here, e by e minus 1 is here. right? Log C base E is equal to is here. If you simplifying this one, 1 by E minus 1 is here. C is equal E power 1 by whatever is here, E minus 1 is here. That is the correct answer. What? The tangent is parallel to the curve, right? The tangent is parallel to the chord AB is here. Then what is the x coordinate? X coordinate is nothing but the direct whatever the C value is asking is here. C value is nothing but the x value is here. How find? Right. Given function is x log x. Right. And the given points are A and B. A comma f of A, B comma f of B. Our interval is AB. Right. 1 comma E is here. Right. The tangent is parallel to the chord AB, which is nothing but the Lagrange's mean value theorem. What is the Lagrange's mean value theorem? There exists a point C belongs to open A comma B, so that f dash C is equal to f of B minus f of A by B minus A. Simplify this one. C is equal to E power 1 minus E is here. Right. Next problem. The value of C in the Rolle's theorem for the function fx is equal to sin power 4x plus cos power 4x in the interval closed 0 comma 5 by 2 is dash. Right. Given function f of x is equal to whatever is here, sin power 4x plus cos power 4x is here, and interval I is equal to closed 0 comma pi by 2 is here. Right. In the given problem, what asking? Apply the Rolle's theorem. What are the C value? Right. We observe what are the Rolle's theorem conditions are 3 conditions. First you observe sin is continuous function. Sin power 4 is also continuous function. Cos is continuous function. Cos power 4 is also continuous function. Sum of two continuous functions is also continuous function. That's why f is a whatever is here continuous function. F is continuous function. First condition satisfied. Right. Next second condition differentiable or not we check. Right. What f dash x is here? F dash x equal to you observe is here. Whatever the 4 sin power 3x into cos x is here, plus the 4 cos power 3x into whatever is here minus sin x is here. Right. So the value is here 4 whatever is here 4 sin x cos x is common is here. Right. Minus 4 sin x cos x is common is here. So what happen is here cos square x minus whatever is here sin square x is here. Here minus is common. That's why cos square x minus sin square x is here. Minus 4 minus 2 into right 2 sin x minus 2 sin x cos x is nothing but the sin 2x. This value is here whatever is here cos 2x can be taken. Cos square x minus sin square. Right. 2 sin A sin B is here. Right. Sin 2AB is here. Sin 2 into 2x is here. Right. That value is f dash x equal to is here minus sin whatever is here 4x can be taken. Right. So in the interval 0 to pi by 2 is here. This all of the finite values is here. That's why f is also whatever is here differentiable function can be taken up is here. And also we observe f of 0. What is the f of 0 value is here? F of 0 is equal sin 0 is 0, cos 0 is 1. Right. And f of pi by 2. Sin pi by 2 is 1, cos pi by 2 is 0. The values are f of pi by 2 is here. Right. So all conditions of the whatever is here Rolle's theorem is satisfied. Right. According to the Rolle's theorem, there exists a point C belongs to open pi comma 2 is here, so that f dash C is equal to whatever is here 0. What is the f dash x is here? Minus sin 4x is here. So that according to this one minus sin whatever is here 4c is equal to whatever is here 0 can be taken as here. Right. Minus sin g minus the value is here minus the value is equal to whatever is here 0. Right. So whatever the minus sin 4c is equal to 0 is here, whatever the c value is here, right, what the c value is here, minus sin 4c is equal to what? 0 can be taken is here. Right. So what about our interval? C is equal to, right, what the c is equal 4c 0 is here. Right. C belongs to the, c compulsory belongs to the open 0 comma pi by 2 is here. Right. So c 0 is right. Right, c is not equal to whatever is here 0. Sin values are 0 at 0 and or multiples of pi is here. That's why c is not equal to 0. Right. And only 4c is equal to what? Pi. C is equal to whatever is here pi by 4 can be taken. Pi by 4 is belongs to the open whatever is here 0 comma pi by 2 is here. You observe c may be 0, but 0 is not our point. Right. Next, where is sin 0? Sin 180 degrees. That's why 4c must be is equal to 180. C is equal to what? Pi by 4 can be taken. Right. That's why, alright, given function, applying the Rolle's theorem in the given interval, we conclusion is C is equal to 45 degrees is here. 45 degrees belongs to our open 0 comma pi by 2 can be taken. What? Given function, interval, applying the Rolle's theorem asking C value is here. So here main twist is differentiation. Right. What differentiation? F dash x differentiation. Right. Applying the trigonometric we get is sin 4x is here, and f dash x is also equal to 0. Minus sin 4c is also 0. Important thing is here. C0 is also sin 0 is also 0, but 0 is not our point. Right. When next sin right, in our interval is here at pi, 4c is equal to pi, c is equal to pi by 4 is here. Here main important thing is differentiation and c value both are applicable, can be taken is here. చూడండి రైట్. సో fx ఈక్వల్ sin పవర్ 4x cos పవర్ 4x అనే ప్రమేయానికి క్లోజ్డ్ 0, అంతరంపై రోలర్ సిద్ధాంతాన్ని అనువర్తింప చేస్తే c విలువ కనుక్కోండి అన్నాడు. రైట్. ఎట్లేంటండి, fx ఇవ్వబడిన ప్రమేయం, అంతరం ఇచ్చినాడు, ఇది అవిచ్చిన ప్రమేయం, f'(x) కనుక్కున్నాం. ఈ f'(x) కనుక్కున్న cos square x minus sin square x cos 2x, రైట్. 2 sin x cos x is sin 2x and 2 sin x cos x is sin 2x is here sin 4x. సో ఇది రైట్ 0, అంతరంపై రైట్ పరిమిత విలువలను కలిగి ఉంది కాబట్టి అవకలనీయం. f(0) is equal to f(i) రెండు సమానం అయిపోయినాయి. రోలర్ సిద్ధాంతాన్ని అనువర్తింపజేస్తే c belongs to open π/2 0, అయ్యేటట్లు f' is equal to ఏం కావాలండి 0. f'(x) ఎంత అండి మైనస్ sin 4x మైనస్ sin 4c 0. రైట్. ఇక్కడ ఏంటండి c 0 కావచ్చు, c 0 అయితే కూడా మనకు మైనస్ sin c ఏమైతే 0 అవుతుంది, కానీ c రైట్ బిలాంగ్స్ టు ఓపెన్ 0 కాబట్టి c అనేది 0 కాదు. రైట్. కాబట్టి ఇక్కడ సైన్ ఎక్కడ 0 అవుతుందండి రైట్ 180 degrees దగ్గర. కాబట్టి 4c is equal to pi అయితే c is equal to ఏమైపోయిందండి π/4. కాబట్టి ఈ సమస్యలో ఇక్కడ ఎక్కడ కాన్సన్ట్రేషన్ చేసినాడండి, డిఫరెన్షియేషన్ దగ్గర కాన్సన్ట్రేట్ చేసినాడు, c దగ్గర కాన్సన్ట్రేట్ చేసినాడు. ఇలాంటి ప్రాబ్లమ్స్ వచ్చినప్పుడు రైట్ సో ఇక్కడ ఈ ఏంటిది c మనకి ఎక్కడ ఉండాలి ఓపెన్ 0, π/2 యూ కాన్సన్ట్రేషన్ ఆన్ దీస్ టూ. ఇన్ దిస్ ప్రాబ్లమ్ యూ కాన్సన్ట్రేషన్ ఆన్ డిఫరెన్షియేషన్ అండ్ వాట్ ద c values can be taken. రైట్. నెక్స్ట్ ప్రాబ్లమ్, the value of c in Rolle's theorem for the function f(x) equal to x³ minus 3x in the interval 0, √3 is dash. Right. You observe f(x) is equal to x³ minus 3x is here and the interval I is equal close to 0, whatever is here √3. This is the given. Right. But applying the Rolle's theorem, you apply fx is polynomial is always continuous, f is continuous function, no problem. First condition satisfied. What the f'(x) is here 3x² minus 3 is here. Right. So in the given interval 0, √3 this all are the finite values. That's why f is also whatever is here differentiable function. You observe f(0) is also 0, f(√3) is also whatever is here, f(√3) is also what 0. Three conditions are satisfied. Right. Continuous, differentiable and f(0) is equal 0 is equal to f of whatever is here √3. According to the Rolle's theorem, there exists c belongs to at least one. C belongs to open 0, 3 is here, so that f'(c) is equal to what 0. Right. Whatever the f'(c) is here, right. This one 3c² minus 3 is equal 0 is here. c² is equal whatever the one, c is equal plus or minus 1. Right. But our c, but our c belongs to open 0, whatever is here √3 can be taken. Right. -1 does not belongs to whatever is here 0, √3 is here. Only +1 belongs to open 0, whatever is here √3 is here. That's why only +1 is correct, -1 is wrong is here. You observe, right. C get two values are there is here. C has the two values are there, but one value is does not belongs to our interval is here. Only right +1 belongs to our interval, -1 does not belongs to our interval is here. Right. That's why C has how many values is here? Only one value can be taken is here. Only +1, not (-1). Why not (-1)? (-1) is not our interval. Right. So what here concentration? Problem is polynomial, continuous and differentiable. F of A is equal to f of B and concentration on C belongs to which interval? Right. Here C has two values is here, but C only one value is our interval. Right. That's why C has the only what the +1, not (-1) can be taken. Right. Next problem. If fx be a monic polynomial of degree 2, satisfy the conditions of the Rolle's theorem in closed 3, 5, then integral 3 to 5 fx dx is equal to dash. It's the most important problem you observe. Right. So fx is whatever is here monic polynomial. Monic means degree 1 of right highest degree of degree whatever is here 2. Means f of x is of the form is here x² plus whatever is here some the ax plus whatever is here b. Right. x² coefficient is 1, that is called monic polynomial. Right. And satisfy the all conditions of the conditions of the Rolle's theorem in the interval closed 3, 3. Right. Closed 3, 5 is here. That means f of 3 is equal f of 5 is here. If these two are whatever is here, f of x is polynomial, f of 3 and f of 5 is equal whatever is here 0, imply x is equal 3, 5. or roots of the equation f of x is here. Why? 3 and f of 3 and f of 5. So both are whatever it is here equal. Suppose equal to 0, 3 and 5 are whatever it is here roots of the polynomial fx is here. Imply f of x is equal to, right, monic polynomial means whatever the x square coefficient is 1. That's why x is root of this fx is here, right, x minus 3 is a factor, and 5 is also a root is here, x minus 5 is also a factor, and monic polynomial x square coefficient is 1. Therefore we get f of x is equal x power 3 x minus 3 into x minus 5 is here. Imply f of x is equal to is here x square minus 8x plus whatever is here 15 can be taken as here. Right. First to find the whatever the polynomial is here. What asking is here? Integral 3 to 5 f of x dx asking is here. Right. Integral 3 to 5 is here. So what the f of x is here? X square minus 80x plus 15 into whatever is here dx can be taken is here. So integration is x power 3 by 3 minus 8x square by 2 is here plus 15x is here within the limits whatever is here 3 to 5 is here. Right. Applying whatever is here 3 to, right, applying the whatever is here 3 to 5 is here. The answer is, if you applying is here, answer is what? Minus 4 by 3 is here. Right. If you simplify, substitute 5 and minus substitute 3, right, substitute 5 is here 5 power 3 by 3 minus 4 into 5 square plus 15 into whatever is here 5 minus whatever is here 3 cube by 3 minus 4 into 2 what the 3 square plus 15 into 3 is here. Simplify this one, you get whatever is here minus 4 by 3 can be taken. What? Your most trick is here, find is fx is here. How find? Right. So fx is monic polynomial of degree 2, satisfy Rolle's theorem on the interval close to 3 comma 5, means f of 3 and f of 5 both are equal. Suppose equal to 0 is here, right, then 3 comma 5 are roots of fx is here. 3 root means x minus 3 is factor, 5 root means x minus 5 is factor, and monic polynomial means fx is x minus 3 to x minus 5. Simplify, you get f of x is here, then integration or differentiation or find the sometimes maximum value, sometimes minimum value, right. This first construct function, then remaining all are sometimes asking the what the maximum value, what the minimum value, right. So what the differentiation, integration asking is here. First here main twisting is finding the whatever the function can be taken, you get the result is here. Right. Next problem, you see, if 0 less than a less than b less than pi by 2 and f of ab is equal tan b minus tan a by b minus a, then what f of ab value? F of ab, some conditions are given. You observe whatever the a and b, what the a and b is here, a and b lies between 0 and pi by 2 is here. Right. Consider the one interval is a comma b is here. Right. You observe what? This is of the form f dash c is equal f of b minus f of a by b minus a is here. That's why our function is f of x equal whatever is here tan x can be take up is here. Right. Then f dash c is equal f of b minus f of a by b minus a, which is nothing but the Lagrange's theorem is here. Right. Now see the what Lagrange's theorem, right, conditions is here. What condition? Fx equal given function fx is equal tan x, I is equal to ab. How consider the tan x? Right, f of b minus f of a by b minus a. You observe whatever the fx is, tan x is continuous function in the interval, open interval 0 comma what? Pi by 2, and also what the f dash x is here, f dash x equal whatever is here secant square x is here, right, which is also a whatever is here in defined in the open interval 0 comma pi by 2. F is continuous and differentiable function. Applying the Lagrange's mean value theorem, there is a c belongs to open whatever is here 0 comma pi by 2, so that f dash c is equal to is here f of b minus f of a by whatever is here b minus a is here. Right. F dash c is equal to, right, what is the f dash c, what is the f dash x is here secant x, f dash c is here secant square c is equal f of b is here tan b minus tan a by whatever is here b minus a. According to the our problem is here, which is nothing but the what is the f of ab is here. Right. What the f of ab is nothing but the whatever is here secant square c, where c belongs to the open whatever is here 0 comma pi by 2 is here. Right. If c is not equal to whatever is here 90 degrees is here, secant square c always whatever is here greater than 1, not equal to 1, equal to 1 at pi by 2 is here, pi by 2 is open, that's why what is the secant square 1 greater than 1 is here. Right. So that's why f of ab value is whatever is here greater than 1 is here. The second answer is correct. What? Indirect applying the whatever the Lagrange's mean value theorem is here. Given interval, right? Why tan is not continuous at x equal pi by 2, that's why open. And f of AB is equal tan B minus tan A by B minus A, and apply the condition of f of AB. It is indirecting asking the Lagrange's mean value theorem. F dash C is equal f of B minus f of A by B minus A. Apply the right condition on f dash C is here. That's why first our interval is AB, no problem. Function is f of B minus f of A tan x. Apply the Lagrange's mean value theorem. You get f dash C secant square C. In the problem secant square C is given f of AB, but right, C belongs to open 0 comma pi by 2. That's why secant square C is always greater than 1, right? Why not if equal to pi by 2 equal to 1, not right, open interval is here. That's why f of AB greater than 1 is here, right? So the applying this condition f of AB greater than 1. చూడండి, right, AB లు 0 కామా pi by 2 మధ్యలో ఉండి f of AB is equal tan B minus tan A by B minus A అయితే f of AB ఏ నియమాన్ని పాటిస్తుంది అని అడిగినాడు, రైట్? అంటే ఇండైరెక్ట్లీ ఇక్కడ ఏమి ఇచ్చిందండి, f dash C is equal to f of B minus f of A by B minus A అయితే f dash C ఎలాంటి నియమాన్ని పాటిస్తుందో అడిగాడు. అంటే మన ప్రమేయం ఏంటండి, tan x, అంతరం ఏంటండి, A to B, right? I is equal to A to B is here. So you can write B less than pi by 2 కాబట్టి tan x అనేది అవిచ్ఛిన్న ప్రమేయం. tan x అనేది pi by 2 వద్ద అవిచ్ఛిన్నం కాదు, కానీ pi by 2 ఓపెన్ కాబట్టి tan x అవిచ్ఛిన్నం. మరి f dash x అంటే secant square x, ఈ అంతరంలో f not equal to 0 is here, రైట్? అంతరంలో 0 కామా pi by 2 అంతరం ఓపెన్లో secant square అనేది పరిమిత విలువలను కలిగి ఉంటుంది. కాబట్టి fx అవిచ్ఛిన్నమైంది, అవకలనీయమైంది. లెగ్రాంజ్ సిద్ధాంతాన్ని అప్లై చేస్తే C బిలాంగ్స్ టు ఓపెన్ 0 కామా 2 వద్ద f dash C is కండిషన్, రైట్? f dash C అంటే ఏంటంటే secant square t is equal tan B minus tan A by B minus A. మన ప్రాబ్లంలో ఏమి ఇచ్చినది, దీన్ని f of AB ఇచ్చింది, రైట్? కాబట్టి f of A is equal secant square C. C అనేది ఎక్కడ ఉందండి, ఓపెన్ 0 కామా pi by 2 లో ఉంది. అప్పుడు secant square C అనేది ఏం కావాలి, గ్రేటర్ దెన్ 1. ఇక్కడ ఎందుకు 90కి ఈక్వల్ కాలేదు, ఈక్వల్ అయితే 1, ఈక్వల్ కాలేదు కాబట్టి గ్రేటర్ దెన్ 1. కాబట్టి f of AB వాల్యూ కూడా ఏం కావాలండి, గ్రేటర్ దెన్ 1, రైట్? కాబట్టి ద సెకండ్ ఆన్సర్ ఈస్ కరెక్ట్. నెక్స్ట్ ప్రాబ్లం, if ABC are the non-zero real numbers, A not equal 0, B not equal 0, C not equal 0, say that integral 0 to 1 plus cos power 8x into ax square plus bx plus c dx, and integral 0 to 2 1 plus cos power 8x ax square plus bx plus c is equal 0, then the equation ax square plus bx plus c will be one root lies between 0 and 1 and another root lies between 1 and 2. Both roots are lies between 0 and 1. Both roots are lies between 1 and 2 and none can be taken is here, right? Here you see the big confusion, very simple, right? First consider the function pi of x is equal to integral 1 to x is here 1 plus cos power 8t into a t square plus bt plus c into whatever is here dt, right? First consider the function is here. You observe pi dash x is equal to, pi dash x is nothing but the integration differentiation is cancelled, 1 power cos 8x is here into ax square plus bx plus whatever is here. See, given pi of x is here, using the �𝗏𝗏𝗁 theorem, differentiate pi of x can be taken, right? You observe here, whatever the pi of 0 is nothing but the integral whatever is here, integral, right? Pi of 0 is integral 1 to 0 is here. You apply, right? Just wait, consider the function pi of 0 is integral 0 to, right? Our lower limits are 0 is here. Here, right, pi of 0 is integral 0 to 0, that function is always 0 is here, and pi of 1 can be taken whatever is here, integral 0 to 1. Integral 0 to 1 already given whatever is here, 0 is here, and pi of 2 is also given integral whatever is here, 0 to 2. Integral 0 to is also whatever is here, 0 can be taken, right? So we apply the what happen is here, right, 1 plus cos power 8t, right, and at square bt plus c, all over the continuous functions is here, implies pi is a whatever is here, continuous function is here, and pi is also, we observe pi is also whatever is here, differentiable function, and also we observe pi of 0 is equal 0 and pi of 1 is equal 0 and pi of 2 is also whatever is here, equal to whatever is here, 0, right? Means apply the right, whatever the apply the Rolle's theorem on the interval 0 comma 1 is here, right? Apply the Rolle's theorem on the interval 1 comma 2 is here. You observe our function pi is continuous and differentiable, and pi of 0 is equal, pi of 1 is equal 0, imply at least what there is at least one point c belongs to open 0 comma 1 is here, so that pi dash c is equal whatever is here, 0. Pi, what is the pi dash c? Pi dash c is nothing but the whatever is here 1 plus whatever is here cos power 8c into whatever is here a c square plus b, right, here c1 is here a c square, right, plus b c1 plus c is equal to whatever is here 0 1, right, cos maximal cos power 8 even function, so that's why, right, not equal to whatever the negative values is here 1 plus cos 8 is not equal to whatever is here 0, only 0 is whatever is here a c1 square plus b c1 plus c is equal to 0, means x is equal to c1 is a root of the equation ax square plus bx plus c is equal to 0 is here, where c1 lies between open 0 comma 1 is here. Same applying the, right, whatever the Rolle's theorem in the interval closed 1 comma 2 is here, pi of 1 0 and pi of 2 is 0, same applying is here, another root c2 lies between open 1 comma whatever is here 2, one root lies between open 0 comma 1 and another root lies between open 1 comma 2 is here, first one is correct, right. What given function, right, so given equation is always polynomial type is integration, then how many roots are there of the equation is here, you observe indirect 1 plus cos power 8 is always not equal to 0, indirect asking is here ax square plus bx plus c is here, right. First construct the function pi of x is here, integral 0 to x is here, right. So 1 plus cos power 8x 8 square plus bt plus c is here. Here asking interval 0 1 and 1 2 is here. That's why we, right, differentiate using the Liouville rule. We get the what the pi dash x is here. Applying the pi of 0 and pi of 1, pi of 2, all over we get direct whatever is here 0 c is here. So that's why we have the 0 1 and 1 to 2 intervals is here. So in this interval satisfy the condition, right. That's why pi dash c 0, 1 plus cos power 8 c1 is not equal 0 and a c1 square plus b c1 plus c 0 in c1 is root. Same applying 1 comma 2 is here, c2 is also root is here. That's why one root lies between 0 and 1 and another root lies between whatever is here 1 and 2 can be taken is here. చూడండి, రైట్, ఏబీసీలు జీరోలు కాని వాస్తవ సంఖ్యలు మరియు ఇంటెగ్రల్ 0 to 1 ఇంటెగ్రల్ 0 to 2 రెండు కూడా 0 అయితే ax స్క్వేర్ ప్లస్ bx ప్లస్ c ఇజ్ ఈక్వల్ 0 సమీకరణానికి 0 1లో ఒక మూలం ఉంటుంది, 1 2లో ఒక మూలం ఉంటుంది, లేకపోతే రెండు మూలాలు కూడా 0 1లో ఉంటాయి, లేదా రెండు మూలాలు కూడా 1 కామా 2లో ఉంటాయి, ఏది కాదు అని ఇచ్చినాడు, రైట్. అంటే మనం చూడండి ఇక్కడ సమాకలన రూపంలో సమీకరణాలు ఇచ్చినాడు, రైట్. ఇక్కడ 1 ప్లస్ కాస్ పవర్ 8 అనేది ఎల్లప్పుడు కూడా ధనాత్మకం, నాట్ ఈక్వల్ టు 0. కాబట్టి మనం దేని మీద కాన్సన్ట్రేట్ చేయాలండి, ax స్క్వేర్ ప్లస్ bx ప్లస్ c మీద కాన్సన్ట్రేట్ చేయాలి. దీనికి అనుగుణంగా మనం ప్రమేయాన్ని ఏ విధంగా చేసినాం, పై ఆఫ్ x ఈక్వల్ ఇంటెగ్రల్ 0 to x ప్రమేయంగా తీసుకుంటే లైవ్విడ్ సూత్రం ప్రకారం దీన్ని అవకలనం చేస్తే మనకు పై డాష్ x వచ్చింది, రైట్. సో ఇక్కడ పై ఆఫ్ 0 కూడా 0 to 0 అయింది, పై ఆఫ్ 0 1 ఇంటెగ్రల్ 0 to 1 ఆల్రెడీ 0 ఇచ్చినాడు, పై ఆఫ్ 2 ఇంటెగ్రల్ 0 to ఆల్రెడీ 0 ఇచ్చినాడు. కాబట్టి సో మనకు పై అనేది అవిచ్ఛిన్నం మరియు అవకలనీయం, పై ఆఫ్ 0 0 అయింది, పై ఆఫ్ 1 0 అయింది, పై ఆఫ్ 2 కూడా ఏమైందండి 0 అయింది. కాబట్టి రోల్ సిద్ధాంతాన్ని 0 1 మీద అప్లై చేయొచ్చు, 1 2 కామా అప్లై మీద అప్లై చేయొచ్చు, రైట్. 0 0 1 మీద అప్లై చేస్తే పై డాష్ c1 ఈజ్ ఈక్వల్ 0 అయితే c1 కానీ రైట్ ఓపెన్ 0 1లో వ్యవస్థం అవుతుంది. పై డాష్ c1 అంటే ఏంటంటే 1 ప్లస్ కాస్ పవర్ 8 c1 a c1 స్క్వేర్ ప్లస్ b c1 ప్లస్ c ఈజ్ హియర్, రైట్. 1 ప్లస్ కాస్ పవర్ 8 అనే ఎల్లప్పుడు కూడా అనేది 0 కాదు, కాబట్టి రైట్ x ఈక్వల్ c1 అనేది ఒక మూలం, అదేవిధంగా 1 కామా 2లో కూడా మూలం. కాబట్టి ఇవ్వబడిన ax స్క్వేర్ ప్లస్ bx ప్లస్ c, రైట్, సమీకరణానికి 0 1లో ఒక మూలం ఉంటుంది, 1 2లో కూడా ఇంకొక మూలం ఉంటుంది, రైట్. నెక్స్ట్ ప్రాబ్లం, if f double derivative less than 0 for all x belongs to open a comma b, then f dash x is equal to 0 has exactly once, at most once, at least once and none. This asking is here, right. At most means maximum is 1, at least means the whatever the at least means 1 or more and exactly whatever is here 1 and none can be taken, right. So now the whatever is here problem depending upon first derivative and second derivative is here. So suppose consider the equation f dash x equal to 0, right. Let the whatever is here alpha comma beta are two roots of the equation in the interval a comma b is here, right. Means f dash alpha is equal to 0 and f double dash alpha is f dash beta is also equal to whatever is here 0, alpha comma beta roots, means is here f dash alpha is equal to whatever is here f dash beta is here, right. Therefore what observation, f is already second derivative exists, right. Means f dash is differentiable is here. So every differentiable function is also continuous, f dash is differentiable, f dash is continuous and f dash alpha is equal to f dash whatever is here beta and the f dash alpha is equal to whatever is here f dash beta is here, right? So therefore what happened, f dash satisfy all conditions of the Rolle's mean value theorem, right? According to the Rolle's mean value theorem, there exists a point C belongs to open alpha comma b is there, say that f dash derivative of C is equal to what, 0, mean f double derivative of C is equal to 0 is here, right? But given f double dash is always negative is here, right? Given f double dash C x always negative is here, so which is a contradiction, which is a whatever is here, contradiction. Contradiction means alpha comma beta are the two roots is here, which is a contradiction, right? That's why two roots are not exist is here, right? May exist, maximum is the two roots are not possible is here, may exist one or, right, less is value, right? So at least one, the no guarantee is here, at most is one, maybe exist, right? The at least one means one root is also there is no guarantee, exactly one rule is also no guarantee is here, at most two roots is not possible is here, at most means maybe one or less value exists is here, so that's why the at most one is correct. చూడండి f double dash x less than 0 for all x belongs to open AB అయితే f dash x equal 0 f dash x equal 0 అనేది ఓపెన్ ఏబీలో కనీసం ఒక్కసారి అవుతుంది, లేకపోతే ఒకటి కంటే ఎక్కువ సార్లు అవుతుంది, ఎగ్జాక్ట్లీ ఒక్కసారి అవుతుందని అడిగినాడు, రైట్? అంటే మనకి ఏమి ఇచ్చిందండి, f dash x equal 0 అనేది ఎన్నిసార్లు అవుతుందంటే f dash x equal 0 సమీకరణం యొక్క మూలాలు కనుక్కోమని అర్థం, రైట్? అంటే f dash x equal 0 సమీకరణం తీసుకున్నాం. సపోజ్ ఓపెన్ ఏబీలో రెండు మూలాలు ఉన్నాయి అనుకున్నాం, ఆల్ఫా బీటా అనేవి రెండు మూలాలు అనుకున్నాం, f dash x equal 0 సమీకరణం. ఆ సందర్భంలో f dash ఆల్ఫా 0 అయింది, f dash బీటా కూడా ఏమైందండి, 0 అయింది. మరి f డబుల్ డాష్ వ్యవస్థమైంది కాబట్టి f dash అనేది అవకలనీయమైంది, ప్రతి అవకలనీయం కూడా ఏమైందండి, అవిచ్ఛిన్నమైంది. f dash ఆల్ఫా ఈజ్ ఈక్వల్ f dash ఆల్ఫా 1 ఈజ్ ఈక్వల్ f dash బీటా అయింది. అంటే f dash ప్రమేయం రోలే సిద్ధాంతం యొక్క అన్ని నియమాలను పాటించింది. రోలే సిద్ధాంతం ప్రకారం, రైట్, సి f dash హోల్ డెరివేటివ్ ఆఫ్ C ఈజ్ ఈక్వల్ 0 అయ్యేటట్లు C బిలాంగ్స్ టు ఓపెన్ ఏబీ వ్యవస్థ కావాలి, అంటే f డబుల్ డాష్ C ఈజ్ ఈక్వల్ 0 కావాలి. కానీ మనకి ఏమి ఇచ్చిందండి, f డబుల్ డాష్ x అన్నది ఆల్వేస్ నెగిటివ్, అంటే 0 కాదు, ఇక్కడ 0 అయింది. కాబట్టి మనం రెండు మూలాలు అనుకోవటం తప్పు, రెండు మూలాలు వ్యవస్థం కావు. రెండు మూలాలు వ్యవస్థం కావు అంటే కనీసం ఎన్ని మూలాలు ఉంటాయండి, ఒకటి లేదా అంతకంటే తక్కువ ఉండొచ్చు, ఒకటి ఉండవచ్చు అనే గ్యారంటీ లేదు, రైట్? సో అట్లీస్ట్ ఒకటి, అట్లీస్ట్ అంటే ఒకటి కానీ అంతకంటే ఎక్కువ ఉండటానికి కూడా గ్యారంటీ లేదు. కాబట్టి అట్ మోస్ట్ అంటే ఒకటి లేదా అసలే ఉండకపోవచ్చు, ఉంటే 0 ఉండొచ్చు, లేకపోతే ఒక మూల ఉండొచ్చు. కాబట్టి రైట్, హౌ మెనీ రూట్స్ ఆర్ దేర్, రైట్? అట్ మోస్ట్ వన్ కెన్ బి టేక్ అప్ ఈజీ. నెక్స్ట్ ప్రాబ్లం, if fx satisfy all conditions of the Rolle's theorem in closed 1 comma 2 is here, then integral 1 to 2 f dash x dx equal to dash. Integral 1 to 2 f dash x dx equal to all, right? What given, f of x satisfy all conditions of the Rolle's theorem in closed 1 comma 2 is here, right? Means f is continuous on closed 1 comma 2, right? And f is differentiable on open 1 comma 2 is here, and f of 1 is equal to f of 2 is here. This is a given data, right? What asking is here, integral 1 to 2 f dash x dx is here, right? What is the integral f dash, right? Integration, differentiation or inverse operators is here, that's why the value is f of x is here, right? f of x at 1 comma 2 is here, f of 2 minus whatever is here, f of 1. But what is the f of 1 is equal f of 2, what, right? The value is equal whatever is here, 0. 0 is the correct answer, right? Given f of x satisfy all conditions of the Rolle's theorem in closed 1 comma 2, then integral 1 to 2 f dash x dx is asking, right? But here f of 1 is equal to f of 2, f of 1 is equal to f of 2, the value is what, 0. చూడండి, fx అనే ప్రమేయం క్లోజ్డ్ 1 కామా 2 పై రోలే సిద్ధాంతం యొక్క అన్ని నియమాలను పాటిస్తే ఇంటెగ్రల్ 1 to 2 f dash x dx విలువని కనుక్కోమన్నాడు, రైట్? ఏంటంటే f అనేది, రైట్, క్లోజ్డ్ 1 కామా 2 పై రోలే సిద్ధాంతం యొక్క అన్ని నియమాలను పాటించింది, అంటే అది అవిచ్ఛిన్నమైంది, అవకలనీయమైంది. f of a is equal to f of b కావాలి, f of 1 is equal to f of 2 కావాలి. మనకి ఏమడిగిన ఇంటెగ్రల్ 1 to 2 f dash x dx. సో అవకలనము, సమాకలనం, విలోమ పరిక్రియలు కాబట్టి ఒక ప్రమేయంపై, రైట్, రెండు అనువర్తింపజేస్తే అది తత్సమ ప్రమేయం f of x వస్తుంది, 1 comma 2 f of 2 minus f of 1. f of 2 is equal to f of 1 కాబట్టి ఈ వాల్యూ ఎంత అండి, 0. 0 ఈజ్ కరెక్ట్ ఆన్సర్.